Hello, everyone. My name is Milan Kaur, and I am a product manager slash developer advocate at Microsoft for Azure Communication Services. Today, we are going to talk about how you can build intelligent applications on .NET using Azure Communication Services. Here's a look at the agenda. I'll talk about the logical layers of an intelligent app, how Azure Communication Channels add value to one or two of these layers. And then I have two demos for you. One is a WhatsApp AI bot for customers' inquiries, followed by a code walkthrough. And then I'm going to show you a phone calling bot that uses telephony as a channel to talk to customers and take orders for a cake on the phone. And again, we'll have a code walkthrough for you. So let's dive in. Since we're talking about intelligent applications, let's take a look at what does it take to build an intelligent app? Like, what are the logical layers of an intelligent application? Well, there are five: source, ingest, store, processing, and serve. So the first three layers highlighted here, they are related to the knowledge base. As you would have heard that whenever we are building an intelligent application that uses generative AI especially, it's important that your AI application responds back to the customer or the user using custom knowledge or data that's very much, about your business or the scenario or the use case, so that the answers that the LLM or small language models are generating are grounded in this data. This process of, retrieving data from a custom knowledge base is called RAG, retrieval augmented generation. We're not going to go into detail about it, but here is a link which has amazing resources for you if you want to learn more about how to do RAG and what are the different ways to do that. ak.ms, RAG hack streams. So do check that out. Now, coming to the last layer, which is serve. This is the layer which the customer or the user will use to interact with your intelligent application. Giving an example of ChatGPT, you can talk to it through the chat interface. You can also talk to it through the audio interface. So the serve layers that ChatGPT is providing is both text-based and audio-based. Now, there can be more ways through which your customers and users can interact with your application. It could be email, SMS, telephony, or even WhatsApp. And two of these we'll see today, the telephony channel and the WhatsApp channel. So last layer is processing. Now, processing layer is sitting between the custom knowledge base and the serve layer. This is where the magic happens. Now, the processing layer will take input from the customer, the user. It could be in the form of a prompt, it could be a question, and then take the answer that's available in the knowledge base related to that inquiry, combine that, take the chat history or the conversation history, and use the power of generative AI to create a response that's best suited for the customer or the user. So Azure Communication Services provides value in the processing and the serve layer. How? Well, Azure Communication Services is Microsoft's intelligent CPaaS, which is Communication Platform as a Service. It provides API-level access to developers to add communication channels such as voice and video calling, chat, telephony, SMS, email, and now even WhatsApp into their applications without having to worry about the underlying infrastructure. So when we're talking about serve, it's self-explanatory that folks can use Azure Communication Services to choose one or more channels to connect with their AI applications. And for processing layer, why the platform matters is because the platform needs to expose the data, be it, chat threads, be it SMS conversation, or be it, raw media stream in a way that can be processed by your backend application so that a correct response can be generated for the customer. Our SDKs are available in all the major languages: Java, JavaScript, Python, and C#. And today, because we are talking about .NET, it's dotnetconf, I am going to focus on C# samples, which are built on the .NET platform. So without further ado, let's start with our first demo. This is a WhatsApp customer service bot Now, imagine a fictitious company called Contoso Electronics, and they serve calculators, not serve, sorry. They sell calculators. And most of their customers are in EMEA and APAC, where WhatsApp is really popular. So they thought, why not create, a customer service bot, which is available round the clock, 24/7, where, users can chat with this bot on WhatsApp on their phone and ask about any problems that they're having with their calculators and get troubleshooting steps. So let's see this in action. So I will be using Azure OpenAI service and Azure Communication Service for this. Now this is my phone screen, which is projected on the laptop. I have opened Contoso Electronics contact, and let's chat with them. Hello. So I get a response, which is welcome back to Contoso Electronics. And I tell them that I have an error code on the calculator. It's not working. And the bot asks me, what is that error code? I respond back 1003. And you can see there is a full text response which tells about the problem and how to solve it. Now, here for this application, I'm using specific error codes that are fed into this app, and I've said that these are the error codes and these are the troubleshooting steps, basically the custom knowledge base. Because if you look at 1002, it's a regular number, it's not an error code. But for this demo purposes, I've fed 1002 as an error code. Now, this is the architecture diagram. In the heart of it is the backend application, which is your application, which you'll write. This application will talk to Azure Communication Services messaging service, which handles WhatsApp messages, and also talk to the GPT models through Azure OpenAI service. Now, on the left is the user. The user is talking through WhatsApp on their phone. In the Azure portal, you have connected Azure Communication Services to the WhatsApp business account so that the Azure messaging service handles the messages that are coming to the number on WhatsApp and passes that notifications to your applications. The application takes the conversation history, takes the system prompt, passes it to Azure OpenAI service to get a human-like response based on the system prompt, and that again is passed from your application back to ACS messaging service, which is rendered as a WhatsApp message on the user phone. Now let's take a look at the code. Now this is the Azure portal. Let me go to the code first, and then we'll come to the portal. So I've shared the link of this code repo in the slides as well. Here you can come and open a new code space on a new branch, or you can use a code space on master. I prefer code spaces to do code walkthrough as well. So let's use that. I just like how it looks here and how easy it is to go through the folder structure. So while that is loading, let me go back to the actual GitHub page. I do want to call out that this sample has a very good README. It talks about all the prerequisites that you need to set this up, and also how you can deploy this application, and how you can troubleshoot if there are some issues. So everything is in there. Experiment with it. So this is loaded. Let me increase the zoom a bit. So here, the main class that you are interested in is webhook controller. Now, this is the class where all the magic is happening. Here you can see there's a system prompt. I have kept the system prompt really simple because the focus of this application was to show you how you can easily add WhatsApp channel into your application. And you can also see that I have the custom knowledge base in the prompt itself. But if you were building something like this for production, you'll have more data. And passing that in the prompt won't be the right approach. So in that case, you'll use some of the RAG techniques that are available, and you can check out the aka.ms link that I had shared earlier to understand which technique will suit you best, and you can follow that. But for demo purposes, for experimentation purposes, it's okay if you want to pass, a little bit of data and system prompt to just get an idea how the entire workflow is happening. Okay, so I'm scrolling down. I want to show you the main function here. So this class is really tiny. It has less than 200 lines of code. And the main function here is handle grid events. That's where everything starts. So handle grid events is the function that will receive notification from Azure Communication Services when the customer sends a message. So when I said hello on WhatsApp, that's when Azure Communication Services messaging will let my backend application know, hey, you have received a message and this is the text of the message. So this is the function that receives that. Here you have to check if the notification type or even grid event type is advanced message received. This is a string that you will use because in Azure Communication Services, WhatsApp messages are referred to advanced messages. So you make sure that you use this for comparison. Once that is done, we retrieve the text, and then you add the text into the conversation history. And then there's a function called respond to customer async. It does two things. It basically calls the Azure OpenAI model to get a generative AI response based on the conversation history and system prompt. And once that is received, it calls another function for sending WhatsApp messages. Now, let's take a look at generate AI response. Here, you can see it's just 4 lines of code. There's a system prompt, and then there's the conversation history. I'm calling the get chat client and complete chat async method of Azure OpenAI client. I'm getting a response. And after that, there are 3 lines of code to send the WhatsApp message. So this is it. This is all you have to do in the code. But there is some setup that is needed to be done. You need to go and create some resources in the Azure portal to be able to run this sample. So let me see. Here is the app settings. You can see that I need something from Azure Communication Services for the WhatsApp channel connection. And then for the generative AI part, I need the Azure OpenAI model. So let's go to Azure portal and see how can we create that. Now, this is the Azure portal. You can come here and type Communication Services, and you can create a new resource. It takes only a few minutes, very easy to create. I will go back to the resource that I have already created. So this is the resource, and you will scroll down on the left page. You will have something called advanced messaging. Here, there's a try advanced messaging option as well. You can use your phone, scan this QR code, and voila, the service will send you WhatsApp message. This is just to try the experience. But for programmatically using this capability, you'll have to connect your WhatsApp business account to Azure Communication Services resource. Again, I have that already connected, but if you want to do it from the beginning, you can do everything from the Azure portal itself. You will come here, you'll click connect, and then check this box. Next, for WhatsApp, you need a phone number that's associated with your account, right? You can either use an ACS number or a number that you already have, because sometimes businesses have a phone number connected to their account and they want to continue using that as well. So that is possible. Now, you'll have to log into your Facebook account. This is because WhatsApp is owned by Meta. So that's where the connection happens. Let me continue to my account. You need a business profile. I have a ton of them created, but you can create a new profile from here. And then you'll also need a new WhatsApp business account. If you don't have one, that can be done from this pop-up as well. And then you keep clicking next, and that's how you go through this workflow. In the interest of time, I'm not going to show you the whole workflow, but my point is that everything is possible within the Azure portal itself. So let's say you created that. After the connection, you'll have something like this on the portal. And this is a channel ID, which is the most interesting thing for you. You'll take that, and then you'll go to keys. You'll take the connection string for Azure Communication Services resource, and then you will put that in your app settings. So this is the connection string. This is the channel registration ID. WhatsApp connection is done with these two app settings. Now we have to go and get the Azure OpenAI resources. So we will go back to the portal. Here, again, you can create a new Azure OpenAI resource by clicking on create. I do have one created already. And here you have to go to model deployments. In model deployments, this is where you basically select which model you want to use. It's 35 turbo or it's 4O mini, whichever one suits your purpose, you choose that. You come to the Azure OpenAI Studio and you can deploy the model from here. There are a ton of models that are good for chat completion. For this, we need just chat completion, text-based. I prefer GPT-35 Turbo for that, but you can choose and select what you want. So this is done. You'll go back to your resource. You'll go to keys and endpoint and copy the key and the endpoint, and you will put it here. Again, the deployment that you created in the Azure OpenAI Studio, you'll put the deployment name here. With that, all your settings in the Azure portal are also done and your code is ready to go. So let's go back to our slide deck. To recap, for adding intelligence into our app, what did we do? We created an Azure OpenAI resource, we created a deployment, and then we also had a system prompt. There is a way to test the system prompt in Azure OpenAI Studio. I did not show that, but you can search for it. We have a lot of content online available. And then you pass the system prompt to the chat completion API. What were the steps we did for adding WhatsApp channel? We created an Azure Communication Service resource. We connected a WhatsApp business account to this resource, and then we got the channel ID and we got the connection string. We used that in our application. The application had something called handle grid events. That is the function that receives notification, and then you can use that in the application. There's one step that I forgot to show you. Let me go back to my application. So here, you need to make sure that your resource knows where your backend application is running so that it can pass the notifications to it. Otherwise, it will not know who to tell when a WhatsApp message is received, right? So within your resource itself, go to events, click on event subscription, and create a new event subscription here. Give any name that you want. In the event, check advanced message received, basically WhatsApp message received. And here you have to select webhook. You configure an endpoint. And sorry about that. You configure an endpoint and you will use your local server where your application is deployed locally. Use DevTunnel or ngrok to get that URL or expose that to the internet. And you can either deploy it in Azure, or so you can use that hosted Azure URL and then just put webhook towards the end and you confirm the selection, and then that connection has happened. So this was an additional step that you must do. Otherwise, your application won't know who is messaging your WhatsApp number. All right, so now it's time for our next demo. In this demo, I will take my phone and call a number, and I expect the number to be, the call to be received by an AI bot, which is basically a bot representing a cake shop. And the bot will be able to take my cake order on the phone. So let's try that.
Hi, welcome to Milan Cake Shop. Are you calling to place an order for a cake?
Yes, I'd like to place an order for a cake, please.
Great. We have a variety of signature cakes and seasonal flavors available at Milan Cake Shop. Do you have a specific flavor in mind, or would you like me to suggest some options for you?
Yes, what do you have in fruity flavors?
We have a couple of fruity flavors available at Milan Cake Shop. Our current fruity flavors are berry blast and mango pistachio. Would you like more information on either of these flavors?
No, that will be all. I'll call you again later. Thank you. Bye. Started to feel hungry whenever I do this demo. Well, so if I wanted to continue, I would have gone ahead and asked about the prices and size and pickup order location and time and would have placed an order. But I wanted to move quick and I wanted to just show you that it is a conversational bot that is talking to me with by using a phone call, telephony or PSTN. So for this, we are using Azure OpenAI service, Azure Communication Service, and Azure AI Search. Here's the architecture diagram. So again, in the heart of this is the custom application, which is kind of coordinating all the different calls. We have used ACS call automation service for this. Call automation service is something that you use when you are building calling workflows. Think of IVRs or think of modern, calling bots like you just saw, where you need to manage what happens at different, junctures of a call. You use Azure Communication Services Call Automation SDK for that. So on the left is a user, and user is making a phone call. ACS call automation receives that call, notifies your backend application that, hey, an incoming call is coming on the number that you configured. And then backend application has the logic of what you do with that call. You accept the call. And in this case, I'm playing a pre-canned message which says, hello, welcome to Milan's Cake Shop. After that, again, when the user says something on the call, like when I said, I want to place an order for a cake, there is an event that gets generated in call automation service, and it notifies the backend application that user has said something on your call. What do you want to do? And now the backend application will take that. Again, like the WhatsApp bot sample, it will append it to the conversation history and pass the Azure AI search index for the knowledge base that we're using for this sample and pass it to the LLM model that you want to use. In this case, I'm using Azure OpenAI Service 35 Turbo again, but again, you can use any model that you prefer. Azure AI Search Index I've used here for retrieving the cake menu and other details about the cake for this application. Because it was a longer menu, I didn't want to pass it into a system prompt, and instead I wanted to use a more sophisticated way to do that. So I've used Azure AI Search. For this sample, we're using speech to text and text to speech as well, meaning when the user is saying something on the phone call, it is getting converted into text, and that text is being passed to a text-based AI model. But you also know that Azure OpenAI recently announced real-time photo real-time model, which can process audio streams. So when that happens, you can expect very low latency when we're talking about conversational term responses. Because you would have noticed that my bot was taking a couple of seconds to respond back to me because I'm using the text model in the sample. But very soon you'll be able to use real-time model with telephony, because Azure Communication Services is going to make some new announcements at Ignite 2024 this year. So stay tuned for our blog, which will go live at this ak.ms ACS Ignite 2024 on 19th November. It'll be on our tech community, so you can go there directly. But we will talk about bidirectional streaming APIs, the newest ones that you can, as developers, then use to integrate with the real-time photo model. So these are the steps that we will first go through in the code, and then I'll come back and do a recap. All right, so this is my cake shop GitHub repo. Again, it is linked. Let's start a code space. And while that is loading, let's go through the README. So here I've also given, sample interactions that have been tested for this sample, and you can try it out as well. There are a bunch of prerequisites because you have to create all the 2 resources that we created for the WhatsApp sample, but you also have to create now Azure AI Search resource. Again, you have instructions on how to create a def tunnel for exposing your locally running service, and you also have instructions on how to deploy this on Azure. So this is a very comprehensive README as well. So I encourage you to try this sample out, clone it, experiment with it, submit a full request if you have some modifications. I'll be very happy to go through it. So this is a minimal API. So it's really, really clean. There's just one interesting class in this program.cs. And again, this class is teeny tiny, only 200 lines of code. Move here, make sure zoom is good enough. Okay. So let's go to the interesting functions here. Now, there are two main endpoints here. One is the API event endpoint. This is the endpoint that your backend application will expose so that Azure Communication Services call automation can let your application know that there is an incoming call. So this is where your call automation service will talk to your application through Event Grid. Now, there's another endpoint that we have exposed. It's called API callback, and it has a context ID for a particular call. This endpoint is used to communicate between ACS call automation and your backend application for all the other events that happens in context of a call once the call is connected. So let's look at the first method, the API event. Here, we check if the incoming notification is an incoming call. There is something that you need to do to connect the cognitive services endpoint. The cognitive services endpoint is basically being used for speech to text, text to speech. If you use our new APIs, which will be announced at Ignite, you will not need to do this step. This is only for text-based models. Now, once the incoming call comes in, you have to answer the call. So you do that. Once that happens, there's a connection that is made. And now for every other event that happens for that call, this particular endpoint will be called. Now, what are the events that will happen? Because we're using an automated flow here, the events that we are interested in is to recognize if the user has said something. For example, as a customer, when I say I want to order a cake, and when I finish my sentence, this is an event where call automation needs to let your application know that the user has said something, and this is what the user has said. So that's the most interesting event that we are looking for. The first one before that is call connected. Once the call is connected, I have a pre-canned message that I'll play, which says, "Welcome to Milan Cake Shop. Are you calling to place an order?" And then I also add that to the chat history, because Azure OpenAI or any other generative AI model needs chat history to get full context to be able to give a response, right? And then we'll skip. This is basically when something fails. How do you want to? The next interesting event is recognize complete, which is basically when the user has stopped speaking something and you want the application to know that. So here, you see that I'm adding those messages and the system prompt in the chat history. And then I'm using chat streaming API in this case. You would have noticed I didn't use that in the WhatsApp bot, because when you're talking about audio, streaming is more important because you want to get the response word by word as soon as it is ready, to make things faster, to reduce the latency. So there's some massaging of this response that I need to do. After that, I call say and recognize. Say and recognize is basically a method which plays the response which was generated by your GPT model, and then place that on the call, which is the phone call here, and then starts listening for the next response that the customer says. So that's it. That's it for the code. Now, let's see what are the different app settings that are required for this sample to work. Now, this first section is about the Azure OpenAI model. We already saw that, how to create it in the Azure portal, so I'm not going to go through that. The second part is, the third part, which I'm highlighting here, which is second in my talk track, is that we need ACS connection string. Now, Azure Communication Resource also be created in the last sample. So do those steps and get the connection string. And then we need a phone number. So this is an additional step we'll do. We need cognitive services endpoint, and we need AI search parameters. So these are the extra steps that we are going to do. And let me take you to the Azure portal. Okay. So where is the one that I'm interested in? Okay. Yeah, this is the one. So this is the resource that I had created for cake shop sample. Here you'll go down and go to phone numbers. You will acquire a new phone number to connect with your application. I already have one. There's something called trial phone numbers as well. So if you want to try things out without paying for a phone number, you can use this functionality. Phone numbers are available for 30 days for phone calling. And if not, you can get a new number. It's disabled here because my tenant is already using the one number that's available to it. If you decide to buy a new number, the cost is really minimal. For example, for me, it's $2 per month for a US toll free. So you can buy a number or you can try phone calling. In case of in case you already have a number, you can also use Azure Communication Services direct routing because most businesses sometimes have a phone number associated with it and they want to continue using that. With ACS, that's possible as well. So once that is done, again, we need to go to Event Grid because that's where ACS knows where to send the notifications to. So we create a new event subscription. This time, instead of advanced messages received, we select incoming call because that's what we want to be notified about. And then you select webhook, you configure an endpoint. So this will be your local dev tunnel URL or your deployed app. The steps are in the README for getting the dev tunnel. And then you will append API event here instead of webhook string that we did for WhatsApp. The reason is that this is the endpoint that we expose, remember, in our backend application. So you will append that and you will confirm selection and your connection with your ACS resource and your backend application is done for calling. Now, let's talk about the Azure OpenAI service. Now, if you have already created a resource, you will go there. And then again, for models, you'll go to manage deployment. And this will open Azure OpenAI Studio. Since we already have something created, you will either use it or you'll deploy a new model. Now, I want to show you another step that you can do through the GUI itself for adding the knowledge base. So come to the chat playground, click on add your data, click on add a source. Here there are a ton of options. We'll select upload files because my cake shop menu was in a Word doc. So this is something that suits me. Again, you will use an Azure Blob storage. You can create a new one from this workflow itself. And then you will you'll select a resource and then you will create a new index here. Once that is done, you can upload the files by dropping it here and it will do the backend work for for creating that index in Azure AI Search. It's that simple in Azure OpenAI Studio. So once that is done, you will come here and you will use the key and the endpoint for your resource, and then you will put that in the application. So you will set that here in Cognitive Services endpoint and, not services, AI search endpoint, AI search key, and the index name that you created in Azure OpenAI Studio. Phone number we've done. The only thing left is Azure Cognitive Services. So let's see how you can do that. So for that, again, you can go back to your portal, click on Azure AI Services, select speech services, and you can create a new resource for the speech service. I already have one, so we will use that. Where are the keys? Here, you'll go to speech and you'll copy the custom voice URL, and that can be used as the cognitive services. Endpoint cognitive services are now called Azure AI services. So with that, you have everything that you need for the app settings of this application, and you're set to use this sample. Now, going back to the slides, a quick recap. How did we add intelligence to our application for the phone bot? We created an Azure OpenAI resource. We deployed a model. We also uploaded the documents that we wanted for the custom knowledge base in Azure OpenAI Studio using the chat playground, where I could just upload the files and get the index. And then we had a system prompt, and we passed the system prompt and chat conversation history into the streaming chat completion API. How did we add the telephony channel? Well, we used ACS for that. We created an Azure Communication Services resource. We got a phone number. If we don't want a new phone number, we can always use direct routing to bring an already existing number associated with the business. And then in event grid, we basically created a new event grid subscription where we added the URL of our backend application so that the communication service resource knows where to send event notification for incoming calls. So with that, we're coming towards the end of our session. Here are the resources, the GitHub repo links for both the samples. I've also put WhatsApp usage pricing link. There are more additional ACS and AI samples that you can check out. For RAG, there's RAG Hack Streams, which has a lot of good content. And then our blog post that will go live on 19th November for Ignite, which will have our latest announcements. You can check that out on our tech community directly, or you can follow this link, ak.ms ACS Ignite 2024. So thank you so much for watching. And here's the link for downloading .NET 9. All right. Thank you, everyone. Bye.